So here is a statement that when the direction of a differential function r vector is constant, then the vector cross product between the vector r and its first derivative with respect to a scalar parameter t is equals to 0. So let's try to prove that. So here we will begin with the definition of a vector valued function, which is a function of t. So this is also defined as we'll take the magnitude of this particular function and then multiply it to the direction of our vector r. The direction of the vector r is given by the unit vector r cap. So let's take the derivative on both sides with respect to t. So we have derivative of r vector with respect to t, so that's equals to derivative with respect to t of r times r cap. So here we have used the fact that r and the absolute value of the vector r, that means the exactly same thing. So here we will use the product rule. On the right hand side we will have the rate of change of r with respect to t times r cap plus r times rate of change of r cap. So this is the vector dr vector over dt. So let's call it equation number 1. Next, what we'll do, we'll take our vector r and we will cross it with the first derivative with respect to t. That means with equation number 1. So that means we take r vector and cross it with this part. So here, since this is a vector, this can only be taken a cross product with a vector. So that will be r cap multiplied to dr over dt, which is just a scalar. Plus here r is a scalar. So that means we have r multiplied to r vector crossed with dr cap over dt. Right. Now r cap, so here r cap will be so we started out this definition. So r cap will be r vector r divided by r. Let's replace it here. So we will get r vector crossed with, so here we have the unit vector, so that's the vector r divided by its magnitude r times dr over dt plus r times, so here we can take the vector r within the derivative, so this can be also represented as ddt of r vector crossed with r cap. So here r vector crossed with r vector, so that's by definition goes to 0. So we have 0 divided by r times dr over dt plus r times. So here we can use the same methodology. So we will replace r cap with r vector over r. Then again we'll have r vector crossed with r. So that means we again have derivative with respect to t of 0. So here also we get 0. So in both the case we have 0. So that means the cross product of vector r with the derivative of r with respect to the parameter t, that is equals to 0. Hence proof.